Welcome. We are about to do lesson 5.4 on modeling and optimization. The title for the section going back is 5.4, Modeling and Optimization. All right, this is a classic problem, one that you've done in pre-calculus. Okay? This almost exact problem is here, and I actually earlier in the year told you about this problem. The difference between pre-calculus fencing problem and calculus fencing problem is A, you have to use calculus. You can't just use other means, non-calculus. And B, these are often no calculator. Okay? So let's crank them out. And on a calculator, it's easy. You just graph it and calculate the maximum, because it'll be a curvy thing and you go the highest, because they're usually maximum. Optimization is what makes the optimum thing, the best thing, the highest thing or the lowest thing. So you have 40 feet to enclose a fence around a rectangular garden along the side of a barn. What is the maximum area you can enclose? I'm going to start a problem like this by just drawing a picture. Please always draw a picture to give you an idea of what's happening. Here is my barn. Just kind of drawing that in. And now on the side of the barn, I need to make a fence. Okay, it's a rectangular fence. So I'll change colors and I'll put the fence in red. Now I don't need to fence the barn side. I just need to fence the other pieces. And question, how long is this? 40 feet, because that's the fence. You only have 40 feet of fence. You want to use it all. You want as big a garden as possible because it says what's the maximum area you can enclose. Identical question, word for word. They might even use 40 in the pre-calc book because our publisher is the same publisher as the pre-calculus book publisher. So where do you start? You know that whole thing is 40, so you got to kind of think about it. Do you know how long the sides are? Not really. So you start making up letters. Okay, so this could be X and X. That's fine. And you could think of this to be Y. But the problem with optimization is this. You can only have one letter. Okay? That's it. You can't have two. So we can't use that Y, so I'm going to delete it. So any thoughts on how we get that side if we know this side is X? William?
40 minus 2x.
That's perfect. It's the whole length 40, but you take away these two top and bottom sides, that guy and that guy. So it's 40 minus 2x. The thing you always want to ask yourself to is what's the question? Luca, what's the question?
What's the maximum area that you can enclose?
Maximum area. Alex, you then need a formula for the maximum thing. In this case, it's area. What's my area formula? Area equals length times width. So you start cranking it out. Area equals length times width. However, you can't use two letters. So actually there's three here, A, L, and W. So you leave the area because that's what you're finding the highest of. And now you got to get these in one letter. That's the hard part of optimization. This wasn't too bad, I hope. But they do get more challenging. So, I don't know, length is x and width is 40 minus 2x. Okay. Now, if I think about it, and I graph my area versus x, side of garden. I don't know, in this case it's x or length or whatever you want to call it. Size of garden. What do you think I'm going to be looking for on the graph? The maximum. How do you find maximums? Take the derivative, set it equal to 0. That's it. I'm going to give you a few minutes. Take the derivative of this, set it equal to 0. I would FOIL, I would distribute, and you can. You can leave it and do product rule if you want. But go for it. Derivative, set it equal to 0, and find the maximum x value. pre-calculus, you would have just graphed this on your calculator and just did the maximum, second calc maximum. But here's all my work now. Everything you have, now I have a digital drawing, which is a little bit better. I defined it as L and W. I switched my barn around and orientated it differently. I distributed the x, and by the way, negative 2x squared is a parabola opening downward. You make sense with all the stuff that you've been taught previously. So please label correctly for the AP people. You then go with A prime, signifying a derivative. You could have did A prime of x if you wanted to. And then 40 minus 4x, bring the 4x or the 40 over, set it equal to 0, and you got a simple 10. Did 10 answer your question? No, don't forget to answer your question. What's the maximum area? So plug in 10 into your side. Obviously this side is 10 and this side is 40 minus 20. So it's 20. So what's the maximum area? Okay, there you go. Perfect. So width and length are 10 and 20, and I hope the last slide I got up here is 200 feet. So there you go. Now, the one thing you have to be careful on is this is just a simple parabola. Parabolas are not that bad because they only have one max or min. This could end up being a cubic or a quartic or a ln or a e to the x or a sine x or all that goofy stuff. So once you do this, if you have multiple maximums, you really got to do a sign chart. Okay? But because this is a parabola opening down, you know it's the maximum. Okay? Now, how would you do a sign chart? You would check if x is 10, you would check at 5 and 15, and see that this goes from positive to negative when you do the sign chart. Therefore, you end up increasing to decreasing, which gives you a maximum. Now, they said 2 slides back, there must be a maximum since the end points are minimum. Okay, end points. Let's think about that for a second. What's the smallest x value you can have? Well, technically you could have 0, but not really 0. It's kind of like an open circle because you can't have a length of a side 0. So you could have 0.00001 if you want to. This really long strip of a fence if you wanted to. So I think that the domain is from 0 parentheses to what? How high can you go for x? I think you could probably go almost to 40, right? 39.999. So your domain is 0 to 40, not including the endpoints, because then you don't got a rectangle. So if you did your endpoints, plugging in 0 for your area, 0 in here, 0 in here, 0, that's 0 times 0, which is 0. And then if you plug in 40, 40 times 40, minus 2 times 40 squared, you get this also. That's why they said I'm not going to check the sign chart because the endpoints are minimums. So of course you can do that because your area would then be 0. Right.
Would you do a sign chart just to see which one is the maximum, or
if there's multiples, you kind of have to,
okay.
Because if there's multiples, your graph might go like this, and then this one is higher than that one. So you do have to check it, and it's definitely not that one because that's a minimum. So you check your sign chart for positive to negative for maximums, and then you compare the values. But that's it. That's what you need to do. This is a classic problem. This is where we always begin. This is just rules for how you always do optimization, because you always do them the same way. Feel free to get them all down if you want. Kind of optional here. But the one thing I want to key on is step 1. Once you write your function, you have to get it in terms of one letter. The hardest section of the year is related rates. That's the week after Thanksgiving. That is cleared away. Everybody usually agrees the hardest section of the year. Except for my last year's class. They thought it was easy. I don't know. I must have got really good last year. I don't know. But related rates you can have 2 letters on. Optimization you can't. You can really only have 1, except for the y equals. And then you find the derivative, set it equal to 0, and check the endpoints if necessary. Okay, you could do a sign chart here also. Okay, kind of option. Right.
So this one, are we gonna have to optimize cylinders and?
Oh, great question. One moment, please. Everybody got this? back to it if you need it, but this is the steps you get. Just want to make sure I'm flipping along.
Oh, here we go.
Oh, look at this, a cylinder. That guy's a genius. He's prophetic. What are the dimensions for a 1 liter cylindrical can that will use the least amount of material? Can you imagine this? You work for a company and you want to make a can so you don't you don't waste a lot of material because you have to buy this metal to make a can. In this case, it's a motor oil can. So, okay, I've made a model of a can. Look at this. Isn't this good? Look at this. Pretty good. It is a piece of paper rolled up. So the question is least amount of material. So you need to know a formula. What formula? What do I use for this in geometry? Surface area. Don't get it confused with volume. If the question said, I want to get the least amount of, the container that holds the least amount, or more likely, a container that holds the most amount, that would be volume. The least amount of material, if you're talking about a little can like this, it's a cylinder. So we need a surface area formula for a cylinder. Anybody remember? It is in the back of your book.
Does it use material for the top and bottom too?
It does. So let's do the top and bottom first. What shape is the top and bottom? Circles. How many are there? 2. So surface area is 2 pi r squared. Pi r squared is the area of a circle. 2 of them, so double it. Now I need, oh, this is a tough part, or is it? Now I need, watch this, shh, don't say anything, I know some of you get it. I need lateral area, or this. Oh, I wonder how you find the area of this thing. Oh, what shape is this? It's a rectangle when you cut it down the middle and unroll it. So the lateral area is just a rectangle. What do we call this part on the can? The height. How do you find this? Circumference. What's circumference? 2 pi r. So here you have it. The top and bottom plus 2 pi rh. What was that, Corey? Too many variables. Shucks. What do we do? Quit?
No.
What haven't we used here? In the problem. It needs to hold 1 liter. It can't hold multiple stuff. It can only hold 1 liter. What does a liter in the real world represent? Liquid or volume. So you have to combine 2 equations. I need my volume equation. What's the volume equation of a cylinder? Pi r squared h. By the way, just so you know, any sort of container, the volume is always capital B times h, and capital B represents area of base. Area of base is a circle, pi r squared. If it was a rectangle, it'd be length times width, times height. Okay, so that's just a general formula. This always works, except pyramids have a 1/3 and cones. All right, so now I have 1 liter. This makes it a little bit more complicated. Let me show you what else I have here. That's the area. Okay, moving on. 1 liter, you have to know a conversion for. There's 1,000 cubic centimeters in a liter. They will never require you to remember this. They'll never require you to know conversions. They will tell you. And the AP exam, they will not use 1 liter. They'll say 1,000 cubic centimeters. But the 1,000 cubic centimeters goes in for what? V. Let's put it in for V. 1,000 equals pi r squared. What h? Why does this help me? Solve for h. It's a substitution method back from your systems of equations in Algebra 1. So let's divide by pi r squared. Divide by pi r squared. Cancel, cancel. You get h equals this stuff. And what do I do with this stuff? Plug it in for h. You guys are good. Then I have a formula with only r. Whoa, this is intense, huh?
I don't like it.
Yeah. It's going to take some practice. It's a little challenging. So I'm going to go back to this. or I'm gonna move ahead, that's what I did, and then I plug it in, and I get this. Oh, there's some simplification that happens too. The one of the radius on the top cancels with one of the radius on the bottom, and the pi's go over. So you technically have this, only r's. Wendy, I need a little help. Once you get the formula, what do you do next? Take the derivative, set it equal to 0. Go! And please don't make your life hassly and do quotient rule. Please don't. You could, but it's a hassle. Do it the easy way. After you're done, check your derivative of what I have on there. I'll show a little work in case if you had a hard time with your derivative of this. That's the way I would have handled it. Negative goes in front. Lower the power. Okay? So that becomes that. Of course, you don't have to put the r in the bottom. Now I have to set it equal to 0. Whoa. Any suggestions on what to do? Common denominators. We've been doing this over and over again on the same problem. So I would suggest to multiply this side by r over, how about r squared over r squared? Then you get common denominators of r squared. This becomes r cubed in the top when you put your r and your two r's together. I didn't do that. What did I do there? Oh, I just put a 0. Oh, I didn't even do that. I did it another way. I moved this to the other side. And you have options here. I moved that to the other side, which is perfectly fine. It doesn't matter, you're going to get the same thing. This way, then, you multiply both sides by r squared. They cancel. And then you get r cubed. Divide by 4. 2,000 divided by 4 is 500. Divided by pi. Cube root, you get that. R equals 5.42.
Yeah.
This one you'd have to use a calculator for. Yeah. This one you would. But they would break it down into steps and asking you to do things. And I'll tell you more about the AP exam on these problems a little bit later. Okay? Because the AP looks a little different on these and it makes it actually easier for you. This is the one section in the book that the problems on the test, I think, are easier than the actual book problems. Corey?
So for the AP test,
Yes.
can you leave it to 500 over pi? If it
Yes.
means
Cube root
just
of that.
put a 500.
Absolutely you can. On the free response section.
Even if it is calculator?
Yes. What's bad about that?
Only two.
It's only 2 decimals. That's one thing that drives me crazy about this slide I grabbed from somebody. But that's it. Did I answer the question? What's the dimensions of the can? What does this stand for?
The radius.
The radius. How do I get a height?
Put it back in.
Plug it back in. That one right there. So there you go. You plug it back into that one. This is challenging. Don't worry. Don't freak out yet. We got 3 days on this plus many days of review. I got one more because this is your homework problem you're going to do tonight. Okay? Here's some notes. I'll get back to that later. This is number 6 from your book. This is from your book and the old book. It's the same number 6. I was going to clip it and redo it, but I just had it from last year, so I kept it. Okay, so you have 11 on.
Alright, I'll be after school with the homework in this. Okay, cool.
All right, the reason why I'm doing this one is because it's a pretty easy problem, but a lot of people freak out by it because it's coordinate plane stuff. And people have a hard time with coordinate plane stuff. So let's talk about it. A rectangle, if you can look at it, you can look at your book too. A rectangle has its base on the x-axis. Another rectangle base on the x-axis. This is x-axis. And its upper two vertices touch a parabola. Ugh. The parabola is y equals 12 minus x squared. This parabola opens down. What's the 12? What's important about the 12? The y-intercept. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's where it is. I'm not going to be too picky on where it touches the x-axis. Let's just go like this. Bloop, bloop. Okay? Because now I'm going to draw this rectangle in. Okay, so let me change colors. I'm going to draw a rectangle. Its two upper vertices are on the parabola, and then let's just make the rectangle because it's on the x-axis, it says. What is the largest area? Look for the word maximum, biggest, or largest. Look for its counterpart words. Area. Write formula. A equals length times width. Start with just the general one, and then know that step one of optimization is make one letter, not two. Okay? So you want this A to be the biggest, but you can't use an L and a W. What are its dimensions? That's all I'm given. When you're doing coordinate plane stuff, use X and Y. Okay? So, take a look at this. Length, width. Question. Right here, what does that represent in a coordinate plane? Right here. That represents y. Okay? If this point was 2 comma 3, you would go 2 over, 3 up. That is your y. I don't know what it is, so I'm going to call it y. What's x? On a coordinate plane. Start at the origin, you just did an x. That's an x. Oh, darn it. So that's only half of this. What's the whole thing? 2x. So my formula is length is 2x, width is y. Oh, golly gee, that stinks because I don't have one letter. Any other thoughts? William?
Wouldn't y equal the initial equation?
Y equals an equation. We haven't used it yet because the parabola could be a different parabola. So y is the same as 12 minus x squared. So this changes to 2x parentheses 12 minus x squared. That's your area formula with only one letter. Don't forget, there's info in the problem you must use. 1 liter, 40 feet of fence, y equals 12 minus x squared. If you're not using something, you're doing it wrong. You got it? There could be a distractor in there, but not likely. Okay? Your next step is to take the derivative, set it equal to 0. Of course you could graph this parabola. Of course you could do negative b over 2a because that's the maximum of a parabola. You could do all that, but that doesn't require calculus, so that will be marked wrong. You have to do derivative, set it equal to 0, and then verify with a sign chart or endpoints or whatever. So you don't have to finish that one because it's an even. I just wanted to show you how to set this up because your homework is the odds. But this is number 6, and 5 or 7 is just like it. So your homework is to do 1 through 11. Okay, it's not too many. The problem is, as you're writing this down, is if you can't set it up, you really can't do it. So the setup is what really kind of messes people up, because people just have a hard time setting these up. That's the only hard part. Derivatives are not hard. Taking equals 0 is not hard. Doing sign charts is not hard. Just the setup with substituting in and getting one letter, that's just the hard part. But that's actually pre-calculus. You should have practiced that about 5 times last year. It's not calculus. So do your best. If you can't set it up, try. Got nothing to lose besides trying. And do your best. That's all I ask. Any questions?